What is up, folks? My name is Dodds, and I am super excited to be your teacher here on egghead.io, where I'm going to take you through the beginner's guide to React.js. We're going to start from the very beginning. So whether you've been doing React for a long time, you just want to sharpen yourself on the fundamentals, or you've never done any React before and you're just kind of curious, this is going to be a perfect place for you because we're going to start with a totally blank slate. When we're using React, we're using a bunch of other tools in the ecosystem around it. You've got a router, you've got state management, you've got the building tools like Webpack or Parcel or whatever it is that you're using. And when you're using all of these tools, it can be pretty difficult to isolate what is React and what is it doing for me. And if you don't isolate it effectively, then you can't use it very effectively. And so we start out with a literal blank index.html file. We write some HTML in it, we write some JavaScript directly in that HTML file, and then poof, all of a sudden we're writing some JavaScript to create DOM nodes, we're inserting those DOM nodes into the page, we're making it dynamic, it's awesome, and then we switch over from regular JavaScript to React. So you get a really good sense of what piece of this puzzle is React solving and how can I use it most effectively in building applications. So then we upgrade to JSX, I show you some tricks of JSX, and then we go all the way through forms and HTTP, error handling, all of that stuff. You're going to love this, and when we get down to the very end, we're going to use some really awesome tools like Code Sandbox and GitHub and Netlify to deploy our application to the world. And so then you can show it to your friends and family and your dog and whoever it is that you want to show this to, because you'll be so excited that you've built something that is available on the World Wide Web with React. It's super cool. So let's go ahead and we'll dive into the workshop stuff so that you can see where the files are, how to get things up and running if you want to follow along, or if you just want to tinker with things as we go. And then we can get into this awesome workshop that I've prepared for you. So the workshop is available to you on GitHub. You'll find it on my GitHub, Dodds/Beginner's Guide to React. I recommend that you switch the branch to Egghead, and that way you make sure that the stuff that you're working with is exactly the same stuff that I recorded in the course. And if we make any changes in the future, that will happen on the master branch. The Egghead branch will always be exactly what you see me do in the course. The course is just a bunch of HTML files plus this start script that we'll take a look at, but you can download this using Git if you're comfortable with that, or you can just click download zip, and that will download the zip file to your computer. You can open that up and extract that, and this is what you're going to find at the end of the day. I am using VS Code, and you can feel free to use Sublime or text editor, whatever it is that you want to, but I recommend VS Code, and it's great. And we've got each one of the lessons right here as HTML files that you can go through, and the HTML file that's available here is the finished version of our code. And so you can work through each one of these after watching the video, tinker around with it a little bit. And to get things up and going, you can actually just open this up. So we can click on Reveal in Finder here, and then we can double click on that and it'll just open it right up in the browser for you. And that will work for lots of these, but some of these lessons actually require that you're running a real server. And there are a couple ways that you can do that if you can figure out how to make that work yourself. But I have this start script, and that's what I'm using. We're using a tool called Browser Sync, and we're using npx to get that running. npx comes bundled with Node, so if you get Node.js installed, then you can use npx. And you can just copy and paste this in a terminal window. That will get Browser Sync up and running, and then you can open up localhost 3000, where that will show you a listing of all the files. We'll go ahead and click on this first one. And then typically in the workshop, I've got this open up side by side with my code editor. So you're going to have it look a little bit like this. And then here you'll notice that I can hit save key and it automatically reloads. And then we'll also want to have our developer tools open. So I've got our developer tools right here. I have that up here at the bottom. And then we have two scripts in here that you don't find in the source code. That's added by Browser Sync. And the cool thing about Browser Sync is that you don't have to manually hit the reload button. You just go ahead and change something, hit save, and it will automatically reload for you. So that's kind of why we're going with Browser Sync. It's really nice for this. And you can feel free to play around with this stuff as we go. You can clear this stuff out and type it out yourself, or you can just wait until I go through the material and then you tinker around with the finished product. Or you can just watch through the whole thing, take notes, and then go through it again later on your own. Whatever works best for you. I do recommend that the first time you go through this, you just kind of watch and take notes, because that typically ends up in a better experience for most people, but you do it however you want to. I can't tell you how excited I am for you to go through this. I've worked really hard to try to make this as approachable as possible, give you really deep foundational understanding without getting too much in the weeds, and I can't wait to see the cool things that you build with this knowledge that you acquire through going through this material. So please do let me know what you build and what you create with this knowledge of React. I can't wait for you to experience this, so let's go ahead and jump into the course. To start, we're going to need a body, and then inside of here we're going to have a div with an ID of root, and that's where our application is going to be mounted. And then we'll have a script, and our type for our script is going to be text JavaScript. And then inside of here we need to get access to this div, so I'm going to make a variable called root element. That'll be document.getElement by ID root. And then I'm going to take this root element and append a child, and we need to append an element to this. So let's create that element with document.createElement. We'll make it a div. And then for this element, we want the text content to be hello world. And then just for fun, we'll have the element.className equal container. So we'll save that and get a refresh here, and now we have hello world. And if we look at the output, we have one thing from that browser sync, but then here is our application at the root. And that's the div we created with the class name of container and the text content of hello world. And then here's our JavaScript code that we wrote. So in review, to create a user interface in JavaScript, you're going to need to have a place where you append your JavaScript generated DOM elements. We're going to get access to that element from the document APIs. And then we'll create our own element. We'll add some properties onto that element, and then we'll append that element to our root element. To use React to create this user interface, we're going to need to have React on the page, and we can get React from npm, but there's a service called unpackage that we're going to use. So if I go to unpackage.com, that will show me how to use unpackage to get any file that is distributed on npm. And it has these files for React, and if I go to that file, then I'll see a minified version of React. So let's go ahead and add some script tags to our page here so that we get React on the page. And with React and React DOM both on the page, I can now create React elements and then use React DOM to render those elements to the page. So I'm going to comment all of this out, and then with React DOM, I'm going to render my element to the root element. But the element that I provide is not going to be a DOM element that I create with the document. Instead, it's going to be a React create element that I create with React. And the API is not exactly the same as the one that we get with document. We do get to specify the type of element as the first argument, but instead of getting the element and attaching properties to it, we actually specify those properties on creation as an object. And another difference is instead of text content, we specify children. So here we'll specify our children as hello world, and then the class name will be container. And this is going to give me my element, which I will render with React DOM to the root element. So if we save this, we'll get a page refresh, and you may not have even noticed that because it's rendering exactly the same thing that we had before. So if we come down here to root, we'll see our div with the class container and the text content hello world. We'll also see those two script tags that we added to add React and React DOM onto the page, and then our own JavaScript that we wrote to create this user interface. So let's take a look at what this element is. If it's not a DOM node, then what is it? We'll console.log the element, save that, and then we'll come over here to our console, and we'll see that we have a $type of property that's a simple. And that's something for React to know that this object is a legitimate React element. We know that the type is a div, And there are a couple other properties that are used by React internally. And then this props object is what we passed as our second argument here with the children and the class name. There's something really interesting about this children prop that I want to show you here. So you can write this same thing as a third argument to React createElement by simply providing the value for the children prop. So here we can provide hello world. And those are functionally equivalent. So if we look at the React element here, we look at our props, and we still are getting children is hello world. And then if you provide another argument, that will be an additional child. So we can say, comma, goodbye world. Save that. We'll get a refresh, and we see hello world, goodbye world, and we get our elements props to be children as an array. And we can continue going on through children forever and ever, or we could take these and use the children prop directly like this, specifying it as an array ourselves. And you'll see that the result here is the same. This also gives us the flexibility of creating additional React elements to be children. So here I could say react.createElement span. We could say we want no props for this span, and we want the children to be hello and world. So we have the type of span, the props are null, the children are an array of hello and world. And if we expand this, we'll see props, children, and children is just another React element that itself has props, and that children is an array of 2 strings. In review, to create React elements and render them to the page, you need to include React and React DOM, React for creating the elements, and React DOM for rendering those elements to the page. Then we still need to get access to some element that's on the page so we can render our elements to that DOM node. And then we create our React elements, and we use React DOM.render to render our element to the root DOM node. Using React to create elements in this way works out just fine, but it's not entirely ergonomic, and it's not the way that most of the community creates React elements. Most of the community is using JSX, which is an HTML-like syntax in our JavaScript. So if I were to create this same React element using JSX, I would make it like this. We'll say element is a div, and our children are hello world. And then we had a class name, which is a prop, so that'll go as an attribute on our div here with class name container. So if we save that, we'll get a refresh, and we'll get a white screen here, and that's because we have a syntax error in our JavaScript. And that's because this is not JavaScript code, this is JSX, and the browser does not understand this natively. So it needs to be compiled from this to something that the browser can understand. And that's where Babel comes in. Babel is a JavaScript compiler supporting the next generation of JavaScript as well as non-standard features like JSX. So if we go to this try it out page and then go over here and copy our code and paste it in here, then we'll see that our code is being compiled to something that's very familiar to us. React createElement, the type is div, here are the props, class name is container, and then all of the children come hereafter. And I would recommend that you spend some time playing around in this tool, because understanding how JSX is compiled will make you more effective at using JSX. In a typical application, you're going to be using a tool that will use Babel to compile JSX to JavaScript for you, but for our purposes, we're going to use Babel in the browser to get this compiling our JavaScript right here without having to install any other tools. So I'm going to add a script tag here to include Babel standalone, and that will compile any script tag that has the type of text Babel, and then it will create a new script tag with the compiled code with the type as text JavaScript so that the browser can evaluate it. So with that, if I save this, we'll get Babel downloaded, it will compile our JavaScript and allow the browser to evaluate it so we can use JSX in the browser. We'll also get this warning that we're using the in-browser Babel transformer, which is not something that you would want to do in production. But it makes it really easy for us to iterate quickly right here in this index.html file. And if we take a look at the elements, we're going to see the code that we wrote in this text Babel script. And then if we go to the head, we'll see a new script tag in here, which is the compiled version of our code. In review, what we wanted to do here was make it so that we can author our UI without using the React createElement API, and instead use JSX, which is an HTML-like syntax for authoring UI. To do this, we need a compiler like Babel, and so we installed Babel standalone, which will compile our code on the fly in the browser. We also had to update our type to text Babel, and Babel will look for all scripts that have that type, compile the code that's inside them, and insert a new script that has the compiled code so the browser can evaluate it. In a typical application, you will not be using Babel standalone, and instead you'll be using another tool, which probably is using Babel, to compile your code. That way you get a much more friendly syntax for authoring your UI with React. So if we wanted to create a variable for hello world and we wanted to interpolate that variable's value into the children position, then I'm going to go ahead and copy this. We'll make this our children. And then we'll come in here, and to interpolate, we're going to use curly braces and put children in here. And anything you put between these two curly braces can be a JavaScript expression, and whatever that expression evaluates to is the value that gets placed into this position for the React createElement call. So we can do the same thing for our class name. If I copy the container, make a class name variable, and then instead of the quotes here, we'll put curly braces to suggest to the Babel compiler that we want this value to be evaluated as an expression, and then we'll pass the class name variable, and if we save this, then we'll get the exact same result as we had before. And you can see the compiled version of the code here in our script tag, where we see we have our children is a variable, our class name is a variable, our element is an assignment to React createElement with our div, and then our object where we have class name being assigned to the variable class name. And we could rename this to whatever we want. We could say my class name, and then copy this and paste it in there. And if we save this, we'll get a refresh, and there it is. My class name is being assigned to the class name property of our object here. And then children is the same thing. So we could say my children, save that, we get a refresh, and there it is. My children being passed as my children. So when you use the curly braces, that's basically telling Babel, leave this alone and pass it directly as the property that you pass for the props here and for the children arguments here. And if we wanted to split these up, then we could do so with world child and do world child. Put them side by side just like that, and we'll get my children and world child. Except to get it to render, you actually need to spell things correctly. That's really important in programming. There we go. And this allows us to be really expressive with the way that we're building our UI. So if we want to add another React element in here, all we need to do is add a span. We can say hello, span, and then we could do a strong, world, strong. And we can get rid of these, save that, and here we go. We get hello, world. And Babel is managing compiling that down to JavaScript that the browser can execute using React APIs. There's another useful JSX trick that I want to show you. So let's come back to our children is hello world, and we'll just call this class name. We'll get rid of this. We'll change this to class name, and then we'll interpolate children here. One important thing to remember is that children is just a special prop that we could actually provide right here. Children is children. And with that, it works exactly the same way as it did before, except now, instead of being compiled to add additional arguments, it's just using the shortcut here as one of the props. In addition, because this is JSX and not HTML, we can have self-closing tags for divs. So we can save that, and this is self-closing. Another thing we can do is if I make an object here, where we have our props, we're going to make children and class name part of those props. Then I can come right here, remove all of those, and I can say, hey, Babel, I want you to take all of these props and pass them to the React createElement call that you create for this div. So we'll interpolate onto this div's props position a spread of that props object. If we save that, then we can take a look at the compiled version of this. We get our props object, we have React createElement, and it just passes the props directly. And then I can add additional props if I want to. I could say ID app root, save that. And in this case, we're going to get the extends helper, which is basically just object.assign. And then Babel is going to extend the props that we provided with the props that we're spreading. So we get a single combined object for the second argument of the React createElement call. And because of the way that object.assign works, if we wanted to override one of the properties in this props object, then we could do so simply by providing it after we spread those props in the props position for this element. So we can say className not container. Save that. And then if we look at the compiled version, we'll see our extends for the props that come before the spread. Then we'll see that object, and then we'll see another object for the props that come after the spread. And then if we look at the result under our root, we'll see we have the ID of approot and the class of notContainer. Approot, because it's not getting overridden, so it appears as is. We get the children as they are, because the children are not being overridden. But then we get the class name of notContainer because we are overriding the class name that's in the props, which comes before class name. So whatever comes last is the winner in the event of a conflict, like we have here. In review, what we learned here is that you can interpolate values with these curly braces by putting any expression between the curly braces and have that expression passed along to the React createElement API. And we also learned that you can spread props in the props position of a JSX element, and those props will be combined with the other props that are provided to that element in a declarative and deterministic way. Let's say that instead of rendering a div with a class name container and then hello world, we wanted to render two spans side by side, one that says hello and the other that says world. So let's first do this with React createElement, and then we'll see how we could do this with JSX. So I'm going to make my element react.createElement span, and we don't need any props, and then we'll say hello. And we'll need another element. We'll call this our world element. And let's call this one our hello element. And this one will say world. And then we need to render those side by side. I don't know how we do that. Let's say hello element and world element. No, it doesn't look like that's going to work very well. Yeah, how do you put two variables side by side and pass them both as the first argument? Well, it's impossible. But if we were to do this in HTML, it would be pretty straightforward. We'd just say span hello and span world, and that would work just fine. So this is straightforward to do in HTML, but it's actually not possible to do with React, which is why the React team created a special type of element called a React fragment. So we can say react.createElement. React fragment is the type, and then we don't need any props for it. And then we can provide both of our children. So let's put this down here. We'll take our hello element, pass that as the first child, and world element, pass that as the second child. And then this is going to get our element that we're going to render. And with that, we have the output that we're expecting. And we could also add an extra child in here to give us an extra space. But again, nobody wants to use the React createElement API directly, so let's comment this out and see what this would look like if we wanted to do it with JSX. So our root element is this React fragment. So we'll do an open bracket and say react.fragment. And we'll close that off with React fragment. And then we'll want to create a span for hello. So span hello span. And then we'll do a space and then span world and close that off. And then if we save this, we're going to get the exact same output, and we're using our React fragment element. Now let's take a look at the compiled JSX here. And you'll notice that we get our element with React createElement, and it's just passing react.fragment as a first argument to React createElement, whereas these, the tag name, is being passed as a string. So the React fragment allows us to put elements side by side without having to have some sort of container element like a div. And this can be really useful when you're creating things like tables that have a really specific structure to them. Because this is so common to do, JSX has a special syntax for React fragments, and that is to simply remove the React fragment and have an open and closing angle bracket. And this is functionally equivalent to what we had before. This syntax is typically what I use whenever I need React fragments. So here we have this div with a class name container, and we have this div with a class name message in here that says hello world. Let's say that I wanted to have, I don't know, maybe two of those. So now we have hello world, and then I don't want to repeat myself, right? So I'm going to make a const message here, that is that hello world, and we'll put that in place of here, message. Just interpolate that there, and now I'm not repeating myself, which is good. But what if I wanted one of these to say hello world and the other to say goodbye world? Well, we need to parameterize this somehow, and when we do that in JavaScript, we create a function. So I'll make an arrow function here, and we'll accept an object. We'll call it props, and then whatever that props.msg or props.message value is what we'll interpolate into the children prop for this div that we create. So now, instead of just putting message in there directly, we're going to call it with an object, and we'll use msg as hello world, and then we'll do this one, msg goodbye world. Save that, and we get hello world and goodbye world, which is awesome. But again, this is not really ergonomic. It doesn't look very good, and one of the benefits to using JSX is the ability for our UI to resemble the declarative nature of HTML. So what I'd really like to be able to do is say message here, and then hello world and message. But if I try to do that, you'll notice we actually do get the hello world, but we're going to get a console warning here saying the tag message is unrecognized in this browser. If you meant to render a React component, start its name in an uppercase letter. Oh, that's interesting. Thank you very much. So let's learn more about that. If we look at the compiled version of our code, we're going to see our message function that's returning a React element that's creating a div. And then if we come down here, we're going to see React createElement message as a string. So that's problematic because we don't want to have the message as a string to create a DOM element that is a message type element. We actually want it to use this function so that we can use this function to create additional React elements. And so, as the warning suggests, we need to use an uppercase letter. And so if instead we say capital message, then we use capital message here. Then let's make sure we don't get errors here. So we'll say capital message for these. Then we can save that. And now we're no longer getting that warning. If we look at our compiled code, we're going to see that capital message here. And when we get past to React createElement, we're going to get a capital message right here outside of a string. So we're passing a reference to the function directly to the React createElement call. And then if we ultimately look at what's rendered to the DOM, we come down here, we see our ID of root, our container, and then we see a div with the class of message. Now let's take a look at what this message element really is. So it's console.log that message element. And we'll look at our console, and we'll see that it is a React element, and its type, instead of being a div like we had before, let's take a look at that to compare. Console.log div hello world. Save that, and we'll get two console logs. So the first one being our div, the type is a string of div, whereas the type here is our message function. And here we get the props of children hello world, and we have children hello world in this one as well. So when you give a capital letter in JSX, that's the same as calling react.createElement with the function that you're referencing. And that allows you to create a custom component that you can use to reuse code over and over again. So let's go ahead and cut this out, and we'll rewrite this using JSX. So we'll say message, and then use the MSG prop because that's what we're expecting. And then we'll come back here, we'll save that, and everything's working without any errors. And if we look at our compiled version of our code, then we'll see that we're calling React createElement with that message function. And then if we wanted to make it nice and declarative so that we could nest these things as if it's the children prop, well then we just accept children for the name of the prop. And then we can rename this one to children, and those two are functionally equivalent. So if we save this, then we'll still get hello world and goodbye world. But honestly, one of those looks a little bit nicer to me, so I'm going to switch both of these to use that syntax. And what's cool about this is I'm also able to nest these together and pass anything that React can render, which includes the string here, or additional components here, or additional elements here. In review, what we did here was we had some code that was being duplicated, and we wanted to reuse that code in multiple places. So we created our own custom function component, which is a function that accepts a props object and returns more React elements. And we had to make sure that our function component started with a capital letter so that Babel would compile this to pass the function itself to React createElement rather than the string message to React createElement. And that way, when React renders our element, it knows what function to call. When you start creating custom function components, you're going to have people using those function components and they may not use it quite right. For example, here we have this say hello that's accepting a props object. We're destructuring it right here. And we're getting a first name and a last name prop and expecting to be able to render those out. But the way that it's being used is we have that first name prop being assigned to false, and we're not providing the last name prop at all. And so the end result is not exactly what we're looking for. The React team has developed a package called PropTypes that allows you to add runtime validation of the props that are passed to your components. This is why React supports a feature called PropTypes that allows you to validate the types of props that are being passed to your components when they're rendered. So to add support for that, we're going to have say hello.propTypes equals this object. And we'll have a key for the prop that we want to validate. And that's going to be a function that takes the props, the prop name, and the component name. So anytime our say hello component is rendered, we can check that the first name prop was passed properly. So we can say if type of props at prop name is not equal to a string, then we can return a new error that says, hey, the component name needs the prop name to be a string, but you passed a type of props at prop name. And if we save that, then we can see that warning shows up. Failed prop type. Hey, the component say hello needs the prop first name to be a string, but you passed a boolean. And we could do the same thing for our last name prop. So what I'm going to do is pull this out. We'll create a last name prop here. And I'm going to make a PropTypes object here where we have a string that is that validator that we just created. And then here we can say first name is PropTypes.string and last name is PropTypes.string. And then we could add a bunch more validators to the PropTypes for numbers and whatever else you could imagine. And then with that, we get a warning for both of these. This is so common that the React team created a package on NPM that we can use, and I'm going to pull it in from unpackage. So we'll paste that right in here, and it's called PropTypes. So with that, it actually creates a global variable here for us called PropTypes when we're using it as a script like that. And it has the same API that we just created, what foresight. So we'll save that, we'll get a refresh, and things are working a little differently. Before we were getting a warning for both the first name and the last name, but now we're just getting one for the first name. And the reason for that is that PropTypes by default are not required. And so because the last name wasn't provided, we're not getting the last name validated in this case. And that works out nicely if you provide a default for the last name, like if we were to say unknown here. But if you want to make sure that it's required, then you can add a .isRequired on both of these. And save that, and now you'll get a warning saying that the first name is the wrong type and the last name is required but wasn't provided. One reasonable concern you might have about PropTypes is that it adds a fair amount of code that needs to be run whenever React is rendering your components, which may impact performance. So let's take a look at the production.minified version of React. And we'll notice that everything is working exactly as it was before, but we're no longer getting those warnings. And that's because in production, PropTypes are not applied. And if you want to take things a step further, then you can actually get a Babel plugin that will remove the PropTypes from your source code for production. And that plugin is called Babel Plugin Transform Remove PropTypes. And so you could install that and use that in your production build, or many toolkits install and use this by default. If you want to learn more about the PropTypes that are available, you can go to the PropTypes page on NPM, and there are a lot of different types that you can use for your components to validate that people are using your components properly. Here we have a React element that is a React fragment, and as its children we have a character count with the text of hello world and a character count with the text of empty string. And ultimately we want this to render the text hello world has 11 characters and the text empty string has no characters. So let's go ahead and implement this. We already have our function component here. We're accepting the text prop and just destructuring it right there. And so what we're going to do is I want to wrap this in a div. And then we want to say the text, and text has text.length characters. And that's for this first case, but we need to interpolate some stuff here. So for this text right here, I think it would be easiest to just interpolate all of this as a template literal. So we'll just do that, and we'll put this inside of curly braces inside of that template literal. And then we'll put an extra space after this. And then for the text length, we can interpolate that right there. We'll save this. And here we have the text hello world has 11 characters. Now let's go ahead and put this text length in a strong element so that it's bold. So we'll say strong, text length, strong, save that. And now it's bolded. And then we don't want to say text length for 0 characters. We want it to say no characters. So let's go ahead and say our length is equal to, if there is a text length, then we'll just say the text length. Otherwise, we'll say no. And then we can interpolate that directly into here. And now we're getting 11 characters and no characters. Thanks to these curly braces allowing interpolation, we could actually take this whole expression and paste it directly into there and get rid of that variable altogether. And that will work just as well. And now let's say we don't want no to be inside of this strong. We only want the strong to be wrapped around an actual number. Well, that will require us to change things up a little bit. So I'll add that right here, and we'll say text.length. So if there is a length, then we want that in a strong with text length. Otherwise, we'll just use the string no. And then with that, let's go ahead and interpolate this character string as a string so we can have an explicit space right there. And then we'll save this. And now we get 11 is bolded and no is not bolded. And it looks like Prettier added this extra space here. It's not really necessary, so I'll go ahead and remove that and we'll get the same result here. Now the reason that I wanted to show you this was to demonstrate what it's like to go between JSX land and JavaScript land and back again. So let's follow the flow of this syntax. When we start in the function, this is JavaScript land. We can do JavaScript functions, if statements, all of that stuff. And then when we do the return and this open parentheses, that's still JavaScript land. We enter JSX land by doing this open angle bracket with the tag. Now we're in JSX land and we have prop syntax and we have children syntax. And then we have our closing tag, and we enter JavaScript land again. Inside of the opening and closing tag, we're in JSX land. And once we do an opening curly brace, we're now in JavaScript land again. But this is a limited JavaScript land because we can only do expressions. We're not allowed to do things like for loops or if statements or any of that. It has to be an expression of JavaScript that evaluates to some value. And so a string like this or a ternary like this, those are expressions and those are allowed within the curly braces. If you stop to consider what this JSX is going to be compiled to, this should all make sense. Let's take a look at the JavaScript code that Babel generates for us. Here we have our character counter. We're calling react.createElement. We pass the div. That's representing this div right here. It's not taking any props, so we get null. And then as the third argument, we get this string. So let's go ahead and write this over here. We have react.createElement div, null for the props, and then the string, the text, and so on and so forth. And so if we wanted to, instead of passing this string, do some sort of if statement, then that wouldn't work at all. It doesn't make any sense to pass a statement as an argument to a function. And for the same reason, you can't use statements inside of the curly braces of JSX. Because the curly braces basically are saying, hey Babel, as you get to this part, I want you to take everything between these two curly braces and then just stick it in this argument of the createElement call. So having a good understanding of how Babel is compiling your JSX will help you use JSX more effectively. Once we enter that closing curly brace, we're back in JSX land, and then we come back to this curly brace and we're now in JavaScript land again. We have this expression, but while we're in the middle of this JavaScript land, with the ternary expression, we actually enter JSX land again. So we're a couple layers into this. We start out in JavaScript, then we go into JSX, and then we go into JavaScript, and then we go into JSX again. And then we go into JavaScript. And we exit JavaScript, we enter JSX, we exit JSX, and we're back into JavaScript, and then we exit JavaScript and go into JSX. And this back and forth between JavaScript and JSX is really common, and this type of interpolation is not unique to just JSX. In fact, we have a couple other examples of interpolation right here. This file is an HTML file, and we start with HTML all right here, and we're still going through HTML until we hit the end of this opening script tag. Now we're in JavaScript land. And we also have style tags, and now we're in CSS land. And so HTML has always had this type of interpolation. JavaScript also has built-in interpolation when we're talking about template literals. Right here, we have this template literal, we're in string land, and then when we do the $curly brace, now we're in JavaScript land. And in fact, this has the same limitations that JSX has for its interpolations, specifically that you can't use if statements or for loops or switch statements in here. Whatever you put in here has to be an expression. And that expression can be complex. We can put ternaries in here, and we could even put an immediately invoked function expression, though I don't advise that. So having a strong understanding of JSX and interpolating JavaScript expressions is really key to using JSX well. And it's something that you'll get better with over time as you're using JSX. We made a clock application. Here it's rendering out the time, and we get that time with new date to locale time string, and then we put that inside of a div and render that. The problem is that it gets out of date as soon as you refresh the page. Every time you refresh the page, you'll get that updated, but you have to keep on refreshing the page, and what a pain that is. So what I want to do instead is I'm going to put this into a function and have that function called every second. So let's go ahead and make that function called tick. And we'll put all of this inside of tick, and then we'll call tick. So we just refactored, just put something in a function. That's a very normal thing to do. But now I'm going to say set interval tick every 1000 milliseconds. So I'm getting that update. And the thing that I want to show you about the way that this is working is if we look in the body and then come down here to our app, we're going to see that update happening on our string right here. And if I were to add something in here, like we put another div, hello, and another div right there, and then paste that time in there, then we're going to notice that the only thing that's updating is this clock time and not this div. Now let's see how this differs if we were to just turn this into an HTML string, and we'll interpolate that. And then instead of React DOM.render, we're going to say root element.inner HTML equals that element. And so now we're getting that same behavior that we had before, except the way that it works is it's updating the entire contents of our application every time, starting from this root element. That's not optimal because it causes a couple problems. Let's take a look at an example. So if I make an input and set the value to that time, and let's go ahead and we'll put 2 in here, then we'll save that, and now we have 2 of those, and they're updating every second. But as I click in here, my focus is going away. And that's because the old elements that were the inputs there are getting totally removed from the DOM, and the new elements are getting put in their place. React doesn't have this problem. So let's go ahead and turn this back into JSX. Just take away that, and the closing quotes, and then we'll remove this and comment that out. Now we're back, and all that we're getting is an update to the values that actually matter for our application, which are the properties for both of these inputs. And this has great implications for the performance of our applications as well as the accessibility, because React is keeping track of our focus for us. Now, this isn't how you normally re-render your application, and typically whenever state changes, you don't have to re-render your entire application, but I wanted to show you this so you have an understanding of what React is really doing for you. When you create these React elements, you give that to React DOM render, or you trigger a re-render of a component, and React is going to compare the elements that you returned this time with the elements that you returned last time. It's going to do a diff of those 2 elements, and then it will update the DOM surgically to only update the things that were different between the last time and this time you returned JSX. We have a bunch of CSS in our HTML document, and we want to style this div with that CSS. So to apply that CSS, we're going to add a class name of box to get that box around this small light blue box. And because we want it to be small, let's also add a box -- small, and we'll save that. And then I want it to be light blue, but we don't have any CSS for light blue, and we could add it, but I want to show you the style prop, which accepts an object rather than a string of styles. So we're going to pass this object, and it will be the same property names that you get if you use getComputedStyle for this element, and that is CSS properties that are camel cased instead of kebab cased. So for us to get a background color, we're going to say background color, and then we want light blue. And with that, we get a small light blue box. Let's also add a font style italic right there. And now we have a small light blue box in italics. Now we also have CSS for large and medium boxes. So let's go ahead and create some more of these boxes. We'll make this one be medium. And using our multiple cursors here, we'll use large for that one. And instead of light blue for our medium, let's do pink. And instead of light blue for our large, we'll use orange. We'll save that. We have this stack of boxes. There's a fair amount of duplication in these, so what I'm going to do is make a new function component called box. This is going to take some props, and then we'll return a div, and we'll spread all the props. So right now, this box component basically functions as a div, and we could replace all of these divs with multiple cursors here with a box. And we save that and we get the exact same result. So now let's make this box a little bit more useful by taking the repetition from each one of these and putting it within the box component. So first off, we have a class name, and then it has a box dash dash, but then the size is different. So let's go ahead and just take the class name box. We'll put class name box, we'll save that. And once we save that, and we can get rid of these as well, then we'll notice that the box class name is no longer being applied because we're not getting that border. And we can verify that by inspecting this, looking at our application, and we see class box small, but we don't see the box class name here. Now think for a moment why that might be. The reason might be a little more clear if I take this spread of props and put it on the other side of the class name. We save that, and now we get the opposite problem where we have the border the class name box provides, but we don't have the small, medium, or large class names applied. The reason is because of this spread of props, we're getting an override of the class name prop that's being provided to the box component. So what we can do is combine the class names into a single class name that will work for all of our boxes. So instead of just taking the props object as it is, I'm going to destructure it in place, and we'll take the class name out of here, and then I'll put a ... rest to say that these are the rest of the props. Then we'll remove this, and we'll put the spread at the end, and then we'll manually combine the class name that we want to provide for boxes in general with the class name that's provided to us through the props. We'll make a template literal here. We'll say box, and then we'll put class name. We'll save that, and now everything's working as it should be. One problem here is that if I take off the class name on one of these boxes, then I'm going to get box undefined. And that's probably not a really big issue, but it's pretty simple to fix by adding a default value for this class name to be an empty string. Now we get box with a space, and I'm not as worried about the space, but if you really were, then you could add a .trim right here, and that would get rid of our space. But I don't think that's a big deal, so we'll get rid of that. And let's restore this small box to its former glory. And the other thing that's common across all these boxes is the font style italic. And so let's have that be provided here, where we'll say style, font style, italic. And then with that, we can actually now remove the font style from all of these. We'll save that. And we've made things a lot more terse for users of this box component, but you might notice we no longer have that font style of italic. And the reason that's happening is the exact same as with the class name. If I move this rest up here before the style, now we're going to get the italic, but we won't get the custom styles that the user of our box component is trying to specify. So again, we do need to compose these manually. And so I'm going to pluck off the style prop from our props here, and we'll combine the style prop from those with the style prop that we specify by using object spread syntax. And then I'm going to put rest at the bottom here again. We'll save that. and we get our italics, and we get our special color, which is exactly what we're looking for. So now anyone that wants to have a box can use this component, and it will have the box class name and italics applied automatically for them. One useful feature of creating components like this is we can use it to separate our user code from the styling concerns of our specific component. So rather than a class name, it would actually be better to accept a size prop. So we could say the size is small, medium, or large. So let's make that work. I'll remove the class name here. We'll save this and scroll up to the top. And we'll see that our small light blue box is no longer small. And now I'm going to take the size prop, and we're going to generate a size class name. And so if the size prop is specified, then we'll say box dash dash size. Otherwise, we'll do an empty string. And then we can put that size class name inside of our class name list here. If we save that, then we get a small light blue box, and users of our box component no longer need to concern themselves with the class name that needs to be applied to create a small box. And this box component can deal with the implementation details of what it takes to make a small box. This means that we could change the class names that we use, we could use a third-party CSS library, and we could change that CSS library, and any component that's using the box just needs to follow the API that the box creates for it. So we can separate our components from the class names used to style them. That said, we can still apply our own class names if we want to, and we can apply our styles if we want to, because those are going to be combined with whatever is happening in the box. So let's go ahead and update the class names for both of these because I like the size prop better. And we'll save that. And now we have a small light blue box, a medium pink box, and a large orange box, with a reusable box component that merges the class name, the style prop, forwards along all of the props like the children prop that we're passing for each one of these, and accepts a special size prop so that you can size the box appropriately. One thing that I want to note here about the class name prop in HTML, we would normally use class instead of class name. Class name is actually the DOM property that you use to access the class attribute on DOM nodes. So if we go here and say $0, which will access the element that we have currently selected in our elements tab, then we can say .className, and that will give us that class name list. In addition, if we were to take all of our props and make a props object here, we just move all of this right here, convert it to JavaScript rather than JSX syntax, and then spread those props, then that will work just as well. But then let's say that this were class instead of class name. If we wanted to extract this and use shorthand syntax here, then we'd make a class variable, and this wouldn't work because class is a reserved word. In addition, if we wanted to leave this here and then destructure the class property from the props, then this also wouldn't work because class is a reserved keyword as well. And so for that reason and others, it is the class name prop rather than the class prop. One thing that I really like about the style prop being an object of styles rather than a string of styles is because it's a lot easier to combine objects of styles. With class name we have a string, and I don't mind that because the order in which I apply these class names has no bearing on which one of these is going to be applied. However, the order in which I apply these styles does have a bearing in what's going to be applied, because if I were to apply this first, then there would be no way for me as a user of the box component to override that, to control what styles are actually going to be applied. All right, let's put everything back where it was and review. So we had a bunch of CSS that we wanted to apply to our divs here to make a small light blue box, a medium pink box, and a large orange box. And we did that manually by making divs for each one of these and applying the appropriate class names and style values. But then, in an effort to reduce duplication, we created this function component called box, which accepts a class name, combines that with the class name necessary to make a box, accepts a style prop, and combines that with the style necessary to make a box with a font style of italic, also accepting a size prop to separate the code for the users of the box component from the code necessary to make a box of that specified style. And then we take the rest of the props and spread that on the underlying div so that users can provide additional props like ID is root, as well as the children prop for the contents of the box. One last thing that I want to show you is Tailwind CSS, which I recommend that you take a look at for building consistent user interfaces. Definitely give this a look for building and styling your applications. And you can apply the same principles that we learned to building custom components that utilize these class names. Here we have an app component that is rendering some JSX here for there have been 0 events, click me, you typed, and then an input here. And we have some state that is running this application component. So if I update the event count to 10, then we're going to see there have been 10 events. If I update the username to hello there and save that, then we're going to see you typed hello there. But the value of the input isn't getting updated, and there have actually not been 10 events. So let's go ahead and wire up things so we can update our state and re-render the app. We already have a function here called setState, which will update our state variable and then render the app. And that will just call react.render on our root again. And this is not typically how you re-render an application or manage state in a React application, but this will work for our purposes of learning how events work in React. So first, let's deal with this button. We have onButtons and onClick event that we can call, and this we're going to provide a function. I can make this an inline arrow function here, and so we'll just say setState, calling this function down here with the new state of an object, event count. And we want that event count to be the current state.event count plus 1. So if we save that, and then I go over here and click, we're going to get an increment every single time I click. And there are a lot of different events that you can use here. We can have an on focus and save that. And every time I focus the input, we're going to get an increment on that event. Or we could say on mouse over, save that. And every time I mouse over, we'll get an increment on that event count. And there are a lot more events that are supported by React. Let's set this back to on count. And then we can also extract this to handle click, and we could put that right here, function handle click, and then we'll call setState there, and that will work just as well. Well, it would work if we used on click instead of on count. There we go. And then let's take a look at this input. So we want this you typed to get updated when we enter some new username. So I'm going to say on blur, and we'll say setState username. And then we need to specify a value here. And what we need is to get the value of the input that is receiving the onBlur event. And so as an argument to the event handler, we receive the event. And then we can use that event to get the target of the event, which will be our input. And then we'll get that value from the input. If we save that, then we can type in Kent C. Dodds and then blur, and our state gets updated. If we want this to get updated as we're typing, then we can change this to on change. And as the user types in this input, we'll get that update to our state and we'll re-render the application. Let's go ahead and pull this on change handler out. So we'll say handle change. We'll bring it up here. Function handle change. We'll take the event. And let's go ahead and take a look at that event. We'll say console log of the event. Save that. We'll pop open our DevTools here, look at the console, and then type in one character. And we'll notice we get a synthetic event object here. That's actually not the native event. The native event is this property native event input event. React does some serious performance optimizations for our events, and that's what this synthetic event thing is all about. Most of the time you don't need access to the native event, but if you ever do, then you can say event.native event, and we'll hit save. We'll type in a character, and we'll get that native input event. But the synthetic event has pretty much all the same properties as a regular event, and so that's what you're typically going to use. One thing I really like about React's event system is that you pass the event handler directly to the element that you want to attach the event to. So it makes following the flow of events and state updates really straightforward. Let's start by making our form. So here we'll have our div, and then we'll make a form, and then we'll have a label with the name and our input, and we'll save that, and we get that form, and then we'll have this message, please type your name, and then we want to associate this label to this input so that it's properly associated, and you can tell that by clicking on the label, and if it doesn't focus the input, then it's not properly labeled. So let's add an ID to our input of name and an HTML4 of name. And HTML4 is like the for attribute in HTML, but in JSX you need to use HTML4. And that's one of the few differences between JSX and regular HTML. So let's save that, come back here, and when I click on name, it now focuses the input. Great, now we're going to have some state here for the name. And if there is a name, then we'll have it say strong hello name. Otherwise, we'll have it say, please type your name. Great, so then if we say Kent, save that, and it'll say hello Kent, but by default, it doesn't say anything. Now let's wire up an onChange handler for this input, and we'll call that handle change. We'll bring that up here and say handle change is an arrow function that accepts an event, and it needs to update the state of the name. So we need to have some way to update that, and we can't simply say name equals event.target.value. That's not going to work because that won't trigger a re-render, and even if it were to trigger a re-render, this whole function would be recalled, and so the name that we would be setting would get garbage collected, and we'd create a new name variable. And so instead, React has what's called a React hook for maintaining state for a component. So we're going to use that with react.useState. We'll pass it the default value of an empty string, and React useState returns an array. We'll call this our state array, and we'll get our name from state array at index 0, and our set name from state array at index 1. And then here, instead of trying to reassign that variable, we'll call set name with the event target value. And if we save that, now everything is working. But nobody wants to write their code like this every time they want to use state. And so we're going to destructure this to be name and set name. Then we can delete those lines and save that, and it's still working. Woo! React rocks. So in review, to use state in a React function component, you use the useState hook from React. The useState hook accepts the initial value, so when this greeting component is initially rendered, that is going to be the value of our name variable. And then anytime we call this second element of the array, our updater function, it will trigger a re-render of this entire function component. And when React useState is called again, it will ignore the initial value and instead give us the current value of that name. And because React keeps track of the order in which these are called, we could add a second one, and here we'll call this name2 and set name2, and we'll make another handle change to handle change2, and we'll have that call set name2, and then we'll just duplicate all of this stuff, put that inside of another div here, and then we'll reference name2 and name2, and this will be handle change2. So now we can say Kent1 and Kent2. And those states are managed independently of one another because React keeps track of the order in which these are going to be called, allowing you to use state as much as you need for your component. And the values in here can be anything. You can make it a Boolean, or you can make it a number, or you could make it an object, or an array, whatever makes sense for the state that you're trying to manage. I want to be able to type in here some value and have that saved in local storage so that when I refresh the page, that value will be retrieved from local storage and be loaded into the input. This is called a side effect, and in React, to do this, you use React useEffect. This is another hook like useState, and this function will be called every time the greeting component is rendered. So anytime the greeting component is rendered, we're going to say window.localStorage.setItem. We'll call it name in local storage, and we'll set it to the value of name. If we save that, and then open our DevTools, and in the application tab here, we can go to local storage, and we'll see that there's nothing in there, and then we can type a name, and we'll see that the name gets updated in local storage with whatever the current value for that name variable is. You'll notice that if I refresh here, I'm not getting that name value loaded into my input, and the value in local storage is getting cleared. This is because we initialize our state to an empty string, and we don't take the local storage value into account. And then because we've rendered, we run this callback, updating the local storage item for name to that new empty string name. So we need to initialize that value to whatever's in local storage if it's there, and an empty string if it's not. So here we'll say window.localStorage.getItem name. And if that returns null because there's nothing in there, then we'll default that to an empty string. And we save that, and we type a name. We hit refresh, and we notice that the value in local storage is still consistent. We notice the value right here is correct, but the name input does not have the name in there. And so we need to specify what the value for the input should be. And so we specify a value of name. Now when we save this, we'll get a refresh, and now the value is the same value that's in local storage and in memory for the state of our React component. And we'll notice that as we change this and refresh, we always get that value from local storage, and we keep that value updated in local storage as well. In review, to make all of this work, we first used React useEffect to set the name value in local storage to the name value in our state in memory. Then, to have our state in memory be initialized from local storage, we used window local storage get item name, and if there is nothing in there, then we'll initialize it to an empty string as a default. And then to make sure that the input is showing the same value for the name as our name in memory, we specified a value prop, changing this input from an uncontrolled to a controlled input. One thing that's important to know about the useState hook is that the initial value you provide here is really important for the initial render of our component, but then it's ignored for renders of our component thereafter. That's normally not a problem, especially if you have just an empty string here, but here we're reading into local storage every time our greeting component is re-rendered, and we can add a console log rendered right here to see how often that is. We open up our console, and we'll see that we already have a rendered here for our initial render of the greeting component. And then as we type, we get a render every time we type a character. But we only needed to read into local storage for the initialization of our state. We don't need to have it read into local storage for every single time we re-render. And this isn't really a huge deal here because reading into local storage is pretty fast and we're not parsing anything. But if we were parsing a big JSON object, then this could be a problem. To combat this, React useState has a lazy initialization feature. You can provide a function as the initial value, and that function will be called to retrieve the initial value. And that function will only be called when it's absolutely necessary to retrieve the initial value. So if we turn this into an arrow function, which simply returns that initial value, then we save this, we'll notice that we're still getting our renders, but this function is not getting called except on the initial value retrieval. And we can prove this by making this a multi-line arrow function, returning that value, and console log hello in here. Now we get that hello, and then we get that rendered. And that's an important note, is that this function is called synchronously, and it's expected to be synchronous. But then as we type hello, you'll see that we do not get that console log hello. And so we save ourselves the expense of reading into local storage on every render. In review, the problem that we're solving here is that reading into local storage is not necessary except for the initial render of our component. And so we turned our initial value argument here into a function so that React will call it only when it's necessary to get that initial value, which is only on the first render. We've added a little bit here to simulate another optimization that we want to make. So here now we have a count state, and that's just being rendered into this button. And every time we click on the button, it re-renders our app component, which triggers a re-render of our greeting component. And every time our greeting component re-renders, this useEffect is going to be called. So if we console log right here, greeting useEffect, then we'll save that, open up our DevTools, and we see we get the greeting useEffect for the initial render. And every time I click this, we'll get another greeting useEffect. But the effect that we're running is updating local storage to set the name to the name value. And so this side effect doesn't actually need to be run because the name value hasn't changed. We only need to synchronize the local storage value with the name value that we have in memory for the state of this component. And so React useEffect accepts a second argument as an optimization to combat this problem. And that second argument is a dependency array, where you pass all the dependencies for your side effect. This is where you pass anything that you want to make sure you synchronize the state of the world with the state of our application. In our case, the only thing that we're trying to synchronize here is the state of local storage, which is the state of the world, with the state of our application, which is the name. And so for our dependency array, we're going to provide the name. If we save that, then we'll notice that we get that greeting useEffect called initially, and that's because useEffect is always going to be called on the initial mount. And then hereafter, when we click on this button, we're not going to get the greeting useEffect. But then when we update the name value, we're going to get greeting useEffect called because the name has changed and the state of the world is now out of sync with the state of our application. And so React is going to call our useEffect callback. It's very important that you keep this dependency array accurate according to the dependencies that your callback function relies on. For example, we rely on name, and that's why it's important that we keep this dependency list in here. If you don't keep this list accurate, then you could be missing out on synchronizing the state of the world with state changes that happen in your app, and your users could lose saved work. For example, if I were to remove the name from this array and save that, then we'll get that greeting useEffect called, and then as I type in here, we'll notice that the state of my application is being kept updated, but I'm not getting any console logs. And so if I refresh, I'm going to be back to what I was before. So I, as the user of this application, have lost work because my code was not properly synchronizing the state of my application with the state of the world outside my application. In an effort to help you avoid making mistakes here, the React team has created an ESLint plugin called ESLint Plugin React Hooks, which you can use to not only ensure that the dependency array is kept up to date, but actually keep it up to date automatically for you using ESLint's fix feature. The rule that will help you with this is the exhaustive depths rule, and I strongly advise that you use this tool and follow that rule. In review, the problem that we were solving here is our effect callback was being called more than it needed to be. I want to make a special note here that just because it was being called more than it needed to be didn't mean we actually had a bug in our application. So this is just an optimization to make our application run a little faster. And a dependency array may not be necessary in all cases. But in our case, we could simply add this dependency array with the one dependency that our effect callback relied on. This callback is only called when necessary. The logic that we have here for storing some state into local storage and keeping it synchronized could be really useful in other areas of our application. Thankfully, React hooks are pretty vanilla JavaScript, and so sharing that logic is just as straightforward as sharing any other logic in JavaScript. What we're going to do is make a function. We'll call that useLocalStorageState, and then we'll move these lines of code into that function, and we'll replace them with a call to that function. And then we need to generalize the code that's in our function. So instead of a name, it might make more sense to call this state and set state. And instead of getting the item with the string name, it might make more sense for the user of this function to provide us a key for local storage. So we'll accept a parameter called key. And instead of this as a default value, it might make sense for people to provide us their own default value. So we'll accept that as another parameter. And we can default that to an empty string just in case they don't want to provide it. And then we'll replace that with the default value. We'll replace the string name with the parameter that we accept called key. And then let's make sure we update these two references to that old state value as well. And then when we call useLocalStorageState, we're going to need to get access to that state updater function and to the state value itself. So let's return state and set state. And we can make our custom hook have a similar API to useState. So it's familiar to people who are used to the useState hook. So then we can come down here, we can get our name and our set name from useLocalStorageState. We'll specify our key as name, and then we're done. That's a pretty straight up refactor from the code that we had before into a custom function. So if we type in here, Chuck, and then refresh, we'll see that Chuck is still in there. One thing I want to call out here is that we prefaced our function with the word use. That's a convention and not required. We could change this to whatever we want, save that, and things will work just as well. And we can hit refresh, and there we have it. But the reason that we follow this convention is because the ESLint plugin React hooks is able to enforce some of the same recommendations and rules on our custom hooks as it is on the built-in hooks, because it acts under the assumption that functions that begin with use are custom hooks. In review, what we did here is we took some code that was in our function component and we moved it into its own function and then called it from our function component. This was no different from any other regular JavaScript refactor, which makes it really easy to share logic across components and even make open source libraries that expose custom hooks like this. We also learned the importance of using the use prefix on our custom hooks so that we follow the community convention and the ESLint plugin can help us avoid mistakes. Incidentally, one such mistake is happening right now because in this index.html file, I can't have ESLint running to show me the mistakes that I'm making, and I made a mistake right here in this dependency array. I wonder if you can figure out what it is. I'm missing one of the dependencies for my callback. Before, we had this key hard-coded as name, so it could never change, so my dependency array didn't need to include that. But now I'm accepting a key as a parameter from the users of the local storage state custom hook, and they could potentially change that value. If they do, then I need to make sure to respond to that change so that I update local storage and not lose any of the user's work. So it's important that in your applications you use and follow that ESLint rule so you can avoid bugs like this. Now with this in mind, we could make this use local storage state hook a lot more robust by removing the item at the old key if that key is changed, but I'm going to leave that as a fun exercise for you to do later. We have a function component called tilt, and thanks to some handy class names and some handier CSS, we have it styled in this fancy looking way, but we can make it do something fancy by using a library that I've included called vanilla tilt. Vanilla tilt takes a DOM node and makes it react to when the user mouses over that DOM node. And the DOM node we want to give it is the DOM node that's created for this element, the tilt root. But remember, this is a React element, not a DOM node. And then React takes that React element and renders it to the DOM. So we need React to give us the DOM node that it creates for this particular React element so we can wire up vanilla tilt to it. To do this, we're going to use a ref prop, and we need to pass a ref, which is an object that has a mutable current property. So let's go ahead and use the react.useRef hook. And from that, we'll get our tilt ref. And then we can copy that, paste it here to our ref. And then the tilt ref is an object that has a current property. And that current property is the current value for this ref object. And in our case, because we're passing this ref to a div with the ref prop, that current property will be the DOM node that React creates for this div. So if we console.log tilt ref.current and we save that, then we should be seeing the DOM node. But we actually see undefined. And the reason we see that is because at the time that this function runs, React has not created the DOM node for this div, and so the tiltref.current is currently undefined. And in fact, you can initialize that current value by passing an argument to the useRef hook here. So how do we get the DOM node so we can initialize vanilla tilt on it? We need to have some code that runs after React has updated the DOM and set our tiltref current property. And interacting with the DOM is a side effect, so the logical place for this would be in a react.useEffect hook. Then if we move that console log in here and we save that, then we'll get a refresh, and now we are getting the DOM node. So from here, we can get our tilt node from tiltref.current, and then let's go ahead and make some vanilla tilt options here. So we can specify how we want vanilla tilt to treat this DOM node. We'll say max 25, speed 400 glare true, and max glare 0.5. And with that now we can say vanilla tilt init on that tilt node and with the vanilla tilt options. And if we save that, we'll get a refresh. This code runs after React has rendered to the DOM and updated the tilt ref current property so that we can get access to the tilt node and initialize vanilla tilt. And now if we hover, we get that really cool effect. Now if we unclick the show tilt checkbox, that will unmount the tilt component from the page, removing the DOM node from the page. However, there are still a bunch of event handlers on that DOM node and several references to that DOM node from within the vanilla tilt library. And so that means that the DOM node itself may not exist on the page, but it does still exist in memory because there are references to it in vanilla tilt. And unfortunately, this could lead to a memory leak. So if we keep on mounting and unmounting this over and over and over again, then we're going to have a bunch of DOM nodes sitting around in memory that really aren't needed by the user anymore. To combat this problem, we can return a function which will be called for every update of our tilt component. And so in this function, we can say tilt node.vanilla tilt, which is a property that vanilla tilt is adding to our DOM node, .destroy. And this will remove all references of our DOM node from vanilla tilt and remove all event handlers so that we can avoid memory leaks with our tilt component. And what you can't see is that that DOM node has actually been garbage collected properly. So we don't need to worry about memory leaks anymore. Another thing that we should do here is recognize that useEffect is going to be called on every re-render of our tilt component. And that's not going to lead to any bugs, but it is suboptimal because what that means is that we'll call destroy with vanilla tilt and then we'll call init with vanilla tilt between every render of our component. And we don't need to do that because none of the things in this function can change with re-renders of our tilt component. And so we're going to add a dependency array here with all the dependencies of our function. And because none of the variables in our useEffect callback can change, we don't need to list any dependencies here. And what this is effectively saying is, I want to run this when the component is initially mounted to the page, and then I want to run this when the component is unmounted from the page. And that's another useful optimization we can make for this case. In review, the thing that we wanted to do was make this DOM node do some fancy stuff. And we included vanilla tilt on the page so that we could do that. And we also included some CSS from the vanilla tilt author to make our DOM nodes look really fancy. And to get access to the DOM node so we can initialize vanilla tilt on it, we're using this ref prop on the div. And we pass the thing that we get back from a React useRef call. That ref has a current property that we can use to access the current value of this object. The reason that useRef is an object that has a current property is so that we can mutate the current property to be whatever we want without triggering a re-render of our component. So we can use refs for more than just DOM nodes like we're using here. We can use it for any value that we want to keep track of and mutate over time without triggering a re-render of our component. After our component has been mounted, our useEffect callback is going to be called, and so we get the tilt node from our tilt ref current property. We create some vanilla tilt options and pass those to the initialization for our tilt node with vanilla tilt. And then we return a cleanup function so that we can remove all references of our DOM node in vanilla tilt and remove all the event listeners that vanilla tilt put on our DOM node. Sometimes it can be really useful to understand the order in which your code is going to be run when you're using React hooks. So I've made this little app that has a checkbox for showing a child, and inside of this box, this will be rendered when that checkbox is checked, and when you click on this button, it's going to increment the count. The way that this works is we have a child component here that's maintaining a count state, and then that has a whole bunch of useEffects here, which are simply logging to the console when the callback is called, and logging to the console in a cleanup function that it provides. And then we create our React element for rendering to the page, and then we log to the console that our render is finished, and then we return that React element we created. We do the same thing for our app component, except here we're maintaining a showChild Boolean state. We have all of those useEffects, and then we render a few React elements here for rendering this UI. So let's go ahead and take a look at what happens when we initially load this page. I'm going to refresh, I'll open up our devtools, and I'll scroll down here to the app so we can follow along in the code with what we're seeing in the console. the first thing that we see is this app render start. So that's the first thing that happens when we call react.dom.render our app. It calls our app function component. The next thing that happens is we call react.useState, and immediately React is going to call this function to retrieve the initial state for our showChild state. And so that's why we're getting this app useState callback called. And then we call all these React useEffects, but you'll notice that the logs in those are not the next thing that appear in our console. Instead, we actually create this element, and then we get a log to the console for app render end. Once that happens, React actually is updating the DOM, and then asynchronously later, it's going to call our useEffect callbacks, one at a time in the order in which they were called. So we come up here to the top, we'll see app useEffect no deps is the first one that appears, and we don't get our cleanup because there's no cleanup necessary yet, because right now we're just mounting the component, and we haven't had any updates yet. Next, we get our useEffect empty deps right here. We have an empty list of dependencies there. And then useEffect with dep, that's our showChild state. And that's the next thing that gets called here. Great, so now let's take a look at what happens when we click on showChild. Remember that this is the last console log that we saw when we initially mounted the component. So if I click showChild, then we're going to get an app render start. When we click showChild, that triggers this on change to set showChild to the checked value of our checkbox input. And this set showChild is going to trigger a re-render of our app, which is why we get our app render start. So we'll come up here to the top again. We'll say app render start, and we'll go through all of this code just like we had the previous render, except this time you'll notice we don't have an app useState callback. We go straight from app render start to app render end. This is because React has already retrieved the initial state value for our showChild state, and it doesn't need to retrieve that value again. So anytime you use a function callback for useState, that function is only going to be called when this component is initially rendered for the rest of the lifetime of that component. So we go through all of these useEffect calls again, we create our element, and then we log to the console that the app render has finished. And then React calls our child to start rendering of that child. One thing that I want to stress here is that we're creating our element, which includes creating the child right here. But you'll notice that we get to this line of code before we start rendering the child. So the important thing to remember here is that just because you create a React element doesn't mean that that React element's function is going to get called, because you're not calling the function, React is. So React will only call that function when that component is actually going to be rendered. And that's really important because you could say const UI I will not render, and render a whole bunch of these all day long. And unless those things are added to some UI that's actually going to get rendered, all that you're creating is a bunch of React element objects, and you won't actually be calling into that child function. So let's go ahead and scroll up to this child render start here. And then we get our useState callback because this is the first time that this useState is going to be called, and so it needs to retrieve the initial value of 0. And then we call all of these useEffects just like in our app. We create our element, and then we get a log for this render end. And then after the entire DOM has been updated, React is going to start calling our useEffects, and it calls them in the order in which they're called, but starting at the child component. So we get child useEffect no deps was called. We get the child useEffect empty deps is called. And then we get the child effect with dep is called. And the dep here is our count value. And then we're going to start calling the app useEffect callbacks. You'll notice that we actually call the cleanup first, and then we call the setup. Here we have the cleanup, and then the setup. And we also do the same for the cleanup when we have a dependency, and then the setup when we have a dependency. And you'll notice that the cleanup for both of these is called before the setup for both of these. And the cleanups are both called in the order in which they appear, just like the setups. You'll also notice that this useEffect callback and its cleanup were not called, and that's because useEffect callbacks are only called if they have no dependencies listed, or if they have a dependency listed and one of those dependencies changed. We have a dependency list, but it's empty, and so therefore none of the dependencies changed because it doesn't have any dependencies. So this useEffect callback and its cleanup will not be called on updates. Okay, let's go ahead and click on this button, and we'll remember that this is the last log that we saw for that last update. So when I click on that button, we're going to call setCount, and we're providing a function updater function where we take the previous value of the state and return the new value of our state. And here we're just going to take the previous count and add 1 to it. And this is going to trigger a re-render. So let's take a look at what happens here. I click on that, and you'll notice that the app has none of its logs called. And that's because the state update actually only resides within this component. So React knows that this component is the only one that needs to be re-rendered. So let's follow the console logs. First, we start with this child render start. We call this again, and we don't get a log for our useState callback because this component's already been rendered and we already retrieved the initial value and we no longer need that initial value. So React doesn't bother calling this function anymore. Then we call all these useEffect hooks. We create our React element for our UI. And then we call this child render end. And then our useEffect cleanups are called in order if those particular useEffects need to be rerun. So in this case, we haven't listed any dependencies, so this will be rerun on every render of this component. So we'll get the cleanup there. This one is listing a dependency array, and there are no dependencies that can change, so it's not going to be called. And this one does have a dependency array, and that dependency did change, so the cleanup is called here. And then we start with the setups for the useEffect that has no dependencies and the useEffect that has a dependency that changed. So this is the last one that was called. And if we click this again, we'll see the exact same order of calls. And then if we uncheck show child, let's go ahead and highlight that so we know which one was the last that we called. And then we uncheck show child. And that's going to trigger a re-render of our app component because we changed that show child state using setShowChild. And so that triggers a render start here. We go through all of this code, again, skipping the useState callback. We come down here, create our elements, and then render end right here. And then we're doing a cleanup on all of the children because the child is being removed from the page. So we're now rendering null. So React notices, hey, the previous JSX that you gave me included the child, and this next JSX that you gave me does not include the child. So that means I need to remove the child from the page. And so I'm going to unmount the component and call all of the cleanups for all of the useEffects that that child had going. So let's come up here and we'll see that that happens in the order in which they appear in the code. So we see our no deps cleanup runs. We'll see our empty deps cleanup run. So even though we have listed dependencies, but none of them change because we have no dependencies, our cleanup is going to run because we're unmounting this component. And then we get a cleanup of the effect with dependencies. Even though this count value didn't change, it's going to be called because this component's getting unmounted. And then because our state changed in the app, we're going to run some cleanup for the useEffects that are relevant. And so here we have this cleanup is getting called because it has no dependencies. This cleanup is not getting called because it has an empty dependency array. And then this cleanup is getting called because the dependency that it has changed. And then we go ahead and run the effects that are relevant. So the useEffect with no dependencies and the useEffect with a dependency that changed. I encourage you to play around with this code example. And also something else that might help you is this diagram from Donovan. You go to Donovan/hookflow on GitHub and scroll down here and you'll see the diagram that Donovan has created. So we get our lazy initializers, so that's our useState callback. We'll get our render function that finishes after the lazy initializers are all called. React will update the DOM. And then React also has a useLayoutEffect hook that will be run here that operates pretty similarly to the useEffect. The browser updates the screen based on the updates to the DOM that React made. And then our effects are going to be called. This is exactly what we observed in our example. And then when there's a state update, we get our render called. Our lazy initializers are not called. React is going to update the DOM. We get a cleanup of layout effects, and then our layout effects are run. Browser updates the screen, and then we get a cleanup of our effects, and then our effects are run. And then when the component is unmounted, we get the cleanup of all of our effects. Having a firm understanding on the order in which these things are called is not totally necessary for you to be effective with React, but it can help you in some situations, so I encourage you to play around with this. So we have this username form, and right now we're just returning to do, but we want to return a form. So I'm going to make a form element here, and then we'll make a div to hold our label username. And then we'll have an input of type text for our username input. And then we'll add a button of type submit. This is our submit button, and we'll say submit. We'll save that, we get a refresh, and here's our form. Awesome. So we could put an onClick handler on our submit button here, and that would work okay when we click on this button, but forms are actually automatically submitted when you hit enter in an input within the form, and people are typically used to that user experience. And so what I'm going to do instead is we'll add an onSubmit handler here, and if somebody clicks on the submit button, or if they hit enter in this input, then our onSubmit handler is going to be called. So let's make a function called handle submit, and then we'll put that handle submit right in here, and we'll console log submitted. We'll save that, get a refresh, say Joe, hit submit, and that's interesting, it goes away. Actually, if you watch closely, you'll see that it does log, but then we get a full page refresh, and we can prove that by turning on preserve log. Then we say Joe again, hit submit, we get submitted and then navigated to that page. Now the reason that this is happening is because when you submit a form in the browser, it automatically makes a post request to the current URL with the form data. And we could see that if we looked at our network tab. But if you want to do some JavaScript stuff based on the user submitted form, then we don't want the full page refresh, and instead we can do our own JavaScript stuff. And so the handle submit function as an event handler will accept an event as the argument, and then we can say event.prevent default. And with that, we will no longer get a full page refresh, and we'll still get the submitted string logged to the console. So our next step is to get the value out of this input because we want to alert the value that the user entered. So we need to get our username equals something, and we'll say alert, you entered username. And we can get rid of that console log here. And then we can say Joe, and you entered question mark. So how are we going to get that username value? Well, one way we could do this, we could say document.querySelector input.value, save that. We say Joe, submit that, and here we go, we get Joe. But that's not going to work very well. It won't scale super well in the real world because the page could have multiple inputs. And if we were to render multiples of these, then they could conflict with one another. So querying the entire document kind of breaks the encapsulation of this component because it means that you can't use this component in the context of other components in an application. So we don't want to query the document. Another thing we can do is we can access the form element from the event. So we could say console.log event.target, and that is going to be our form element. So we say Joe, submit that, and we'll get the form element right there. And that's great, but let's take a look at some of the properties on that form element. And Chrome is rendering out this really cool DOM tree, similar to what we see in the Elements tab, but I want to see the properties that are on the form element. So I'm going to use console.dir, which will log out the properties of that element. So we'll say Joe, submit, and here we go, we have our form. And here, there are a bunch of properties on here. We can see there's a 0 and a 1 for input and button, so we could actually say username is event.target, and we want 0.value. We save this, we get Joe, and we get our you entered Joe alert showing up. So that works out nicely, but I'm gonna get the username from another one of these properties. Let's see, we've got elements right here, and elements has a 0 and a 1, so we could say event.target.elements at 0.value and save that, and that will work as well. But I'm not super jazzed about relying implicitly on the order in which these form elements appear, because if I were to add another input right here, then I'm going to be toast. You entered undefined. So I don't want to rely on that. There's another thing that we can do here, and that is by properly associating our label to the input by having an HTML for username input, and then having an ID of username input right here. Now the label and the input are properly associated, meaning that I can click on the label and it will focus on the input, which is good for accessibility. And when I say Joe in here, hit submit, then we look at our form and our elements property. And now in addition to the 0 and 1 indexes for each of these elements, we also get this username input value here because the ID of this element inside of our form. You actually get the same thing using the name attribute as well. We look at our form elements and we see that username input still exists right there. So any elements that have a name or an ID will be attached by that name and ID to this elements property of the form node, and you can reference those by those names and IDs. So that's what we're going to prefer here. We'll say username equals event target, that's our form, dot elements dot username input dot value to get the value out of that username input. And with that, we can say Joe, and we get everything working exactly as we want without the implicitness of querying the entire document or relying on the order of the elements. Another thing that we could do is make a ref for our username input. So we'll say username input ref equals react.useRef. And then we could say ref equals username input ref. And instead of this, we could say username equals username input ref.current dot value. So username input ref.current will be the DOM node for the input, and we'll get the value from that. And this will work as well. So there are a couple ways to do this, and I'll go ahead and add username equals document query selector input dot value. But the reason that I removed that is I really want you to please not use this. It breaks encapsulation of our components, and that's one of the things that we really love about React is that we can encapsulate logic within our components. I don't recommend this method or this method because those implicitly rely on the order in which the elements are rendered and could easily break if you change that order. Either one of these will work just fine. Personally, I think that if you don't need a ref for the input, that it's just easier to retrieve the input from the event target elements. And it's recommended that you use HTML4 and ID to associate labels to inputs anyway. And so given that you already have to do that, this I think is the simplest way to get the value from the inputs in your form. So with that in mind, let's go ahead and get rid of all of these. We'll get rid of that, clean this up, and remove the ref. And if I were writing this form today, this is what it would look like. In review, what we had to do here was we created a form that has a single input and label associated to that input and a button with the type of submit. It's really important that any button you put inside of a form has a type because implicitly it will have a type of submit, and that's not entirely clear, especially if you say cancel for the contents. With no specified type, that gives this button a submit type, which is really confusing. So if you do want to have a cancel button or a reset button, then you want to specify the type is button, which I know is a little redundant, but if you don't specify a type, then the type will implicitly be submit, which would really confuse your users when they try to click cancel. So we specify that type is submit. We put in submit for the value here. And then instead of putting an onClick handler on the button, we put an onSubmit handler on the form, and that way any other way that the user tries to submit the form, we'll call our submit handler. And then to avoid a full page refresh, we use event.preventDefault, and then we retrieve the user's input using event target to get the form, and then elements to get the elements of the form, and username input to retrieve the input by its ID. Then we get the value from that input to get our username, and then we alert that to our users. Or you can submit this to a backend server. Let's say that this username form cannot have uppercase characters, they can only have lowercase characters. Well, we could show the user an error when they hit the submit button, but it would be a lot better user experience if we display an error message as they're making changes to this input field if they change it to something that's not allowed. So we need to know what the user is typing as they're typing it, not just as they submit it. So we're going to add an onChange handler right here. And here we'll call this handle change. And we'll make a function, handle change, and that will take the event. And then we can use event.target. And because the target of this handle change event is our input, then event.target is going to be the input, .value is going to be the username. But we need to store that username somewhere and trigger a re-render of the username form so that it displays the error message if the username is typed incorrectly. So let's go ahead and add some state to this username form. We'll say username and set username equals React useState, and we'll initialize that to an empty string. And then in here, we'll call set username with the event target value. And then we no longer need to get the username from the form input elements because we're always going to be keeping this username up to date with whatever the user is specifying. So we can get rid of that. And now this username is just referencing that. Next, let's go ahead and determine whether this is lowercase by saying username equals username.toLowerCase. So if it's equal to its toLowerCase version of itself, then we know that it is lowercase. And we know that we have an error if it's not lowercase. If it is lowercase, then we'll just say the error is null. Otherwise, we'll say the username must be lowercase. And then we just need to display that error message. So we'll copy that, come down here, and make a div here with a style color red, just for the fun of it. And we'll put the error message right in there. And then we can also make the button disabled if there's an error. Disabled accepts a Boolean, so we'll just say Boolean error. And so if error is truthy, then we'll pass a true value for disabled. And if there is no error or it's falsy, then we'll pass a false value for disabled. So let's save that. We'll get a refresh, and if we type an uppercase character, then we'll get username must be lowercase. The submit button is disabled. And if we type a lowercase character, then we don't get any problem until we get an uppercase character in there. So if you ever need to know exactly what the user is typing as they're typing it, then you can use the onChange event to get access to the value of the input and update that in the state of your component. Then changes to that value will trigger a re-render of your component, and that state value will be whatever the user has typed, allowing us to create this error message based on whether the username is lowercase. And then we display that error message here in red in this div, and we disable the submit button if there is an error message. It's great that we're able to display an error message if there's an uppercase character and we disable the submit button, but it would be even cooler if we didn't allow the user to type uppercase characters in the first place. So if they try to type an uppercase character, we just lowercase it for them. And we could do that pretty easily just by saying set username.toLowerCase. And now the username that's stored inside of our state is going to be lowercase. And so we can do uppercase forever. When we hit submit, that's all going to be lowercase, but it's not exactly a great user experience to be able to type something here and have the end result be different from what I submitted. And so what we need to do is control the input value to be exactly the same thing that I have in my state, because I'm programmatically changing the value that I get from the input to set the value that I store in my state. And if I want to keep those two in sync, then I need to control the input's value. And to do this is pretty simple. We simply add a value prop here, and we'll pass in the username. And as soon as we pass this value prop onto an input, we're communicating to React that React no longer needs to manage the state of this input, and now we are going to control that state, and it should not change that value to anything other than what we enter in here, which includes whatever the user is typing. So if I save this, and I come back up here and I try to type an uppercase string, that's not going to work. It's going to lowercase my string for me automatically. So now it's impossible for me to type something that's incorrect. Now it might be useful to have some sort of info thing here that indicates why I can't type uppercase characters in here, but hopefully you get the general idea that if you ever need to make the input value something different from what the user is actually typing, then you can do so by passing a value prop. Let's go ahead and clean some stuff up here because we no longer need to display an error because it's impossible to make an error now. We'll get rid of that submit here. We'll get rid of the is lowercase and error right here. And we can save that and everything looks great. You can't tell, but I'm holding down the shift key. I promise I'm trying to type something uppercase. But the value in the input isn't uppercase because I'm setting the username to a lowercase version of what's being typed in that input's value. And then when React re-renders this component, the username which is all the lowercase characters, is getting passed into the value of the input, and React is setting that input's value to the lowercase version of what it was. As hard as you work on your application, sometimes unexpected things will happen. I don't expect people will be throwing errors in the body of your function, but they could be calling functions that don't actually exist, which will result in an error. And so let's take a look at how you can manage these with React. So here we have some explode state where we initialize that to false. And then we have a button where when you click on it, it changes that explode state to true. And then we also render this div where if there is some explode state, then we'll render that bomb, which will trigger this error. So if we take a look at what things look like right now, we click on the bomb and our entire application goes away. We get this uncaught error kaboom in our console. And if we scroll down here a little bit, React actually logs out a component stack trace so we can track down which component threw this error. So we have our app and that is rendered right here. And then we have this div, which is rendered here. And then we have this div, which is rendered here. And then we have this bomb, which is rendered here. And that bomb is the thing that threw the error. And then it's giving us this tip. Consider adding an error boundary to your tree to customize error handling behavior. So that's just what we're going to do. Normally, I use a third-party library for this, but we're going to build our own little error boundary. And error boundaries have to be class components. And to create a class component with React, we're going to say class error boundary extends react.component. Now in the body of our React class component, we're going to need a render method. And this is what's going to be rendered. It's basically the same thing as the body of our regular function components. And so here, we're actually not going to render anything special with this error boundary. We're simply going to return this.props.children. So the React elements we return for this error boundary are going to be the same React elements that are provided to this error boundary as children. So let's go ahead and put those right here inside of this div. We'll say error boundary, paste in what we had before, and then close off that error boundary. And now if we save this, we get a refresh, and when I click on this bomb, we get the exact same behavior that we had before. So now let's make this error boundary handle that error. The first thing that we're going to need is some state. So we'll say error is null, and then we'll have a static method called getDerivedState from error that'll accept an error, and then it'll return the state change that we want to make based on this error. So we'll just return an object that has an error property, and that's going to be assigned to the error that we're getting for this static method. And when this happens, we're going to get a re-render. And so let's grab that error from our state. And then we can say if there's an error, then we'll return a div that says, oh no. Let's save that. And when we click this, we're going to see, oh no. We'll still see errors logged to the console for our benefit, but the application won't completely crash. React will simply re-render this error boundary with the error that was thrown, and the error boundary gets to control what's being rendered. I'm going to go ahead and make a function component here called error fallback, which is going to be my generic fallback component for this application. We'll make this accept a prop called error, and then we'll return a div that has a p tag with something went wrong, and then a pre-tag with the error message. And then as the user of this error boundary component, I want to be able to provide to the error boundary the fallback component I want it to render when there's an error. And so I'm going to provide it the prop fallback component. And here I'll provide that component that I just created, this error fallback. Paste that right in there. And then for our error boundary to accept and render that, we're going to have access to that fallback component on this.props. So we can say this.props.fallback component, and we'll provide the prop error as error. You may recall that rendering custom components requires that the first character you use is capitalized, but the compiler also has a rule that if there are dots included in the component name, then those will also be treated as custom components, which is why this works. So if we save this, we push the button, and we're going to get something went wrong, kaboom, the app is still working, and we get all of the information logged to the console as well. Now, as I said, I never use class components, even for error boundaries, because I prefer to use a third-party library, which I'm going to include now, and that is called React Error Boundary. With the React Error Boundary UMD export, it exposes a global variable called React Error Boundary, and it has a property on there called Error Boundary. And I'm going to simply assign that to Error Boundary. And you'll be pleased to know that I don't have to change any of my code for this to work. It'll continue to work because we basically built a simple version of the error boundary from this library. The library is doing a fair bit more than what we're doing here, which is why I recommend you do that instead, but the API is exactly the same. One other thing I want to demonstrate here is that this error boundary can be rendered anywhere in the tree, but the location of the error boundary has special significance. So the error boundary can handle any errors that are thrown by its descendants. But it's also important to note that the error boundary is going to render something in place of all of its descendants when there is an error. So that means that while we can see the bomb still right here and the rest of our application, if we were to move this error boundary up to encompass our entire app and save that, when we click this button, then the entire app is replaced by our error fallback component. This may or may not be desirable based on the specific use case, but it could be useful to have one error boundary rendered up here, and then other error boundaries rendered throughout your application with more specific error fallbacks. So here we could have something went wrong there, and that error is going to be handled by the nearest error boundary here. But then if something went wrong somewhere else in our application, then this top level error boundary could handle that error. And this gives us some fine-grained control over what part of the tree is going to be replaced by what's rendered by our error boundary. Another important thing to note is that our error boundary can only handle certain errors, specifically errors that are happening within the React call stack. So it won't handle errors that are happening in event handlers, or if there's an error in an asynchronous callback, like a promise handler. It will only handle errors that happen within a React call stack, like the render method or a React useEffect callback. So in review, to handle React errors, you need to create an error boundary, or, as I recommend, use React error boundary from npm. With this error boundary, you can wrap parts of your code, and any descendants of that error boundary will have its errors handled by the error boundary. And with the error boundary from the React error boundary library, you can provide a fallback component, and that fallback component will be rendered in the event of an error, allowing you to recover from the error or simply display an error message for the user to read. Here we have an app that's managing some items, and we can add items and remove items. We have a fixed set of items that can be added or removed, and we have a button to add additional items, which is disabled when we've added all of our items, and then we iterate over the items that we have and render a list item for each of those. And so here we have remove buttons for each one of these, and then the item name itself and an input with that item in it. But when we render this, we're going to get this warning that says each child in a list should have a unique key prop. So what that's talking about is anytime you render an array of React elements, in our case we're rendering these LIs, each one of those React elements must have a key prop associated with it so that React can track these appropriately over time. Don't be fooled by this syntax. There's nothing really magic going on here. What we're doing is we're taking an array of strings, we're mapping over that array of strings, and turning that array of strings into an array of React elements. Specifically in our case, these are LI elements. And so that's the case where you need to have a key prop for every React element in the array, and we're seeing this warning because we don't. So to fix this warning is actually pretty simple. We look at the items that we're iterating over, and that is this array right here, and each one of those items has an ID that uniquely identifies the item. And so we're going to use that ID as the key prop. So here we'll say key equals item.id. If we save this, we don't get that warning anymore. But I'm not a huge fan of changing my code just to make warnings go away. I like to understand why that warning is there in the first place, and so that's why we have this contrived example for me to show you. So here we have a list of each one of these items where the item itself is the label, and then the default value for the input is the item as well. And then we can remove these and add them, And as I removed them, if you watched carefully, you might have noticed an interesting bug. If I click on remove here, and remove, and remove, and remove, everything works out just fine. But if I remove from the beginning, now we're having orange being associated to the apple, and grape is associated to orange, and pear is associated to grape. So that's kind of interesting. If I remove from the middle here, now we have pears associated to orange, and orange is associated to apple. Things are all kinds of messed up. And this is the bug that the key prop helps you to avoid. If you consider what happens when we click this remove button or this add button, then this strange behavior will make sense. When we click on remove item, for example, if we try to remove the grape, then that goes into this code right here, which calls set items, and that sets the items to the same list of items that we had before, except we're filtering out the item that you were trying to remove. This call to set items is going to trigger a re-render of our app. And so the app is going to come down here. We're going to create these React elements. We're going to iterate over this list of items, which now has one less item than it had before. And we're going to hand that off to React so that it can update the DOM appropriately. The way React updates the DOM is that it has a reference to the JSX elements that you gave it the last time it rendered this app component, and it compares those React elements with the new React elements that you just returned at this time, and then it updates the DOM accordingly. So when you're giving it an array of React elements, unless React has some sort of identifier to know which element is which, it doesn't know whether you removed an element, or maybe you added 3 and removed 4, or maybe you changed the order and just removed the first one. It doesn't have any insight into what it is that you did to this array of React elements between the last time it rendered and this time. And so anytime you're rendering an array of React elements, you need to give it a key so that it can determine whether elements were removed, added, or modified. And that's why providing a unique key for each one of these items is going to fix this problem. And now if we click remove on the grape, all of the inputs and their labels are correct. You'll notice also that if you try to provide some key, where it's the same key for each one of these, you're going to get a warning there because it encountered 2 children with the same key. And keys need to be unique so that components maintain their identity across updates. Non-unique keys may cause children to be duplicated and or omitted. The behavior is unsupported and could change in a future version. So hard-coding a specific key that's duplicated across these elements could lead to some very unexpected behavior, and we still experience that bug that we had before. So the key that you provide for each element of this array of React elements needs to be unique to the item that you're rendering. And typically that's going to be some sort of ID, as in our case. Another mistake that I see people make sometimes is they try to use the index as the key. And while you get rid of the warning, you do not get rid of the bugs. And that's because as React is comparing the previous version with the new version, what you're saying is the element that was at index 4 is actually now at index 3, but React doesn't know that. And so it maintains the state for this input to be the same as the one that was at index 3 the last time, rather than being the one that was in index 4 last time. So it's really important that you keep the key as something that's unique to the item that this element in the array is representing. Here's another little demo that I have at the bottom of this file. I'm just going to uncomment that. We'll save this and we'll get a refresh. And in this example, we have those items, and every 1000 milliseconds we have this interval that shuffles those items and triggers a re-render with that shuffled version of the items. So we randomize the items every time. We have 3 versions of this. One that renders those items as inputs without a key, another that renders those items with inputs with the key of index, and then the last that renders those items with an appropriate key. And you'll notice that they're all updating correctly, meaning that they're all jumping around the screen as they should, but the focus is not updating correctly. So I'm focused on Apple right now, and when that one moves, my focus doesn't go around with Apple. Also, if I try to highlight one of these, then my highlight goes away as well. You'll notice that the with key as index suffers from the exact same problem, and even though it's not getting the warning in the console, you're still not fixing this bug. Only when you have a key in there will your focus travel around with the input that it's actually associated with, because React is able to determine where to move the focus as your component updates. In review, it's really common in React to take an array and map that array to an array of elements and render that directly in your JSX. When you do that, it's really important that you add a key to the root React element of each element in the array so that React can track changes over time and make sure that it preserves the state of each element in the array and its descendants. Here we have a simple app component where we're managing some name state, so we can pass that to our name component and pass it to our display component so that we can render out, hey, name, you are great. We also have a favorite animal right here that's managing its own state and rendering the input with the value and an onChange handler. Now let's say that this display component, which is a sibling to our favorite animal component, actually needs to know what the animal is, because instead of you are great, we want to say your favorite animal is, and then animal right here. So we'll accept that as a prop. But how are we going to get access to that animal if that state is living in our favorite animal component? These two are sibling components, so the favorite animal component can't pass the animal to the display component. Well, let's keep on going. So we're going to need to accept an animal, and that's going to come from somewhere. We're not sure where yet. But from the looks of things, we're going to need to do the same thing to our animal state that we're doing with our name state. And that is specifically, we need to lift the state from the favorite animal component to the app component, which is the least common parent between these two components. So let's do that. I'm just going to grab this and I'll move that down to right here. And now the favorite animal doesn't have access to animal or set animal. So I'm going to accept an animal and an onAnimal change. And we'll do the same thing that we did for our name component. So onAnimal change will be passed to the onChange prop, onAnimal change, and the animal gets passed along to the input. Then we come down here to the favorite animal, and we need to pass the animal and onAnimal change. And we'll just paste in what we had before. And now our display has access to the animal. If we save that, then everything should work, except this is misspelled. So let's do animal. There we go. Great, so now we can say Mulan, and Mulan's favorite animal is dragon, but specifically Mushu. What we did here is what's called lifting state. So typically you want to have your state as close to the code that's using that state. So that's why we had the state in this favorite animal component. But when we had a use case for a sibling component to have access to that state, we had to lift that state to the least common parent, which was this app component, and we put it right there. And then we pass that state and the mechanism for updating the state, which is our setAnimal function, as props to the components that need it. So here for our favorite animal, we're passing the animal prop and an onAnimal change prop. So we have a mechanism for updating that state. And then here for the display, all it needs is the animal. So that's all that we pass. Once you learn how to do this, it becomes kind of second nature. But one thing we're not quite as good at is pushing state back down or colocating state. So let's say that our display use case gets changed and we no longer need to pass the animal down. So we're going to say, you are great again, and we no longer need this animal prop. Often people will actually just leave it right there without making any other changes. But we need to remember that we no longer need to accept this animal prop on this display where we're rendering it. And because the animal state is only being used by a single component, that means we can actually move that state back into that component to get it collocated. So let's move it back up here. We no longer need to accept either one of these props. And we can come down here, grab that, remove both of these props, and then we'll paste that onChange event handler back into our favorite animal input onChange prop. And with that, we've co-located our state, making it easier to maintain our application in the long term. In review, what we did here was we explored how to lift state and then push it back down with state co-location. Our app component here is rendering out some state, which does need to be used by multiple elements, so our app is maintaining the name state. And then we also had this favorite animal, which is maintaining its own state, but then our display component needed to have access to that state, so we lifted the animal state up to the least common parent, which was our app component, and then we passed that state and a mechanism for updating the state down to the components that needed those things. And that was the lifting state part. And then we did the reverse to push the state back down for state colocation by moving the state back to where it was before, removing the state from the component that doesn't need it anymore, and removing the props that are no longer necessary. And this enhances both the performance and the state management maintainability of our application. Here we have an app that's managing a Pokemon name state, and then we're rendering out a form, and we're rendering an input, and every time we submit our form, we're going to update the Pokemon name to whatever the user typed in the input. And when this is re-rendered, we're going to render the Pokemon info with that Pokemon name, and then the Pokemon info should render out information based on that Pokemon. So if we type in Pikachu, then we should request some information for Pikachu. But we need to get that information by fetching it from a server. And so we have this helper function here called fetchPokemon that creates a Pokemon GraphQL query, and then we're using window.fetch to fetch to this public API that has Pokemon information. We're making a post. We have our proper headers to accept JSON. Then we serialize, and then we specify our body is a JSON stringified version of our query, and then the variables for our query, which is the name of the Pokemon. Then when that promise resolves, we're going to take the response, parse it as JSON, and then when that's done, we'll get that response object and pluck the Pokemon off of the data in the response. So we can call this function to get the information for this Pokemon that we get as a prop, but our render method here has to be synchronous, and our fetchPokemon function is asynchronous. Making HTTP requests like this is a side effect, and so we're going to use the React useEffect hook. So we'll say react.useEffect. And the first thing that I want to say here is if there's no Pokemon name, they haven't entered a Pokemon name yet, or they submitted an empty one, then we'll simply return. We don't need to make a request for that. Otherwise, we'll call that fetch Pokemon with the Pokemon name, and then in our success handler for this promise, we'll get the Pokemon data, and we can set some state. So let's go ahead and manage some state for this. We'll have useState for Pokemon, and then we'll call set Pokemon, and we'll initialize this to null. And then down here, let's rename this from Pokemon to Pokemon data, and then we can call set Pokemon with the Pokemon data. So then down here, we can say if no Pokemon, then we will return just a ... to indicate that we're loading. Otherwise, we know we have the Pokemon data, and so we can render it right here. So let's just JSON stringify this. So we'll put that in a pre, so we get the right spacing. We'll say JSON stringify Pokemon null2 to get nice spacing for our JSON. We'll save this. We have a ... right here. Because there's no Pokemon, then we can enter in Pikachu, submit that, and we get Pikachu's information. Interview to do anything asynchronous, that is a side effect that needs to happen inside a useEffect callback. So for our Pokemon info, we accept that Pokemon name, and in our callback, if there is no Pokemon name specified, then we'll simply return. Otherwise, we'll fetch the Pokemon data with that Pokemon name, and then when we get that data back, we'll update our own state to have that data. That'll trigger a re-render of Pokemon info, and then we can return the stringified version of that Pokemon data. Now we could apply an optimization here to make sure that this useEffect only runs when we want it to by putting Pokemon name in here, and that way this useEffect will only rerun when the Pokemon name changes. And we could also add an if statement here for if there's no Pokemon name supplied, then we could say return submit a Pokemon. And with that, we get submit a Pokemon. Then we can type in something like Pikachu, submit that, and we'll get Pikachu's information loaded up. Now, what would happen if there was some sort of server error, or maybe we made the request incorrectly? Let's take a look here. Let's go down to our query, and we'll make a typo. We'll say nam instead of name, and we'll save that. And then when I type in here, I can say mu and then submit. And as a user, I'm just going to see this ... That's not going to be useful at all. let's see what's going on here in our developer tools. I'll go ahead and refresh. We'll type mu again. Let's clear out our network tab, and then we hit submit. And we're going to get a network error indicating that we cannot query field name on type Pokemon. And it gives a suggestion for did you mean name. But the specific error is beside the point. We just need to show the user something a little bit more useful than leaving them in a loading state forever. So let's come back up here before we fix our code, and let's add some state for the error state. We'll say set error, we'll initialize that to null, and then we'll say if there's an error, then we'll return, oh no, ... And in a real application, maybe you'd be a little bit more helpful than that. But let's add an error handler here as a second argument to our then call, and this will be our error data. And we'll say set error with the error data. So then we can submit that, and we'll type the Pokemon name again. We see, oh no, and now we need to try again. The problem that we'll face now is that if the user does try again and the server is successful, the way that we have our code structured is not going to work with that. So what I'm going to do is I'm going to add a new state here for status. We'll have set status, and we'll initialize that status to idle. Meaning right now the Pokemon info is not doing anything useful. And so then we can say that the idle status is when we want to render submit a Pokemon. So if the status is idle, then we'll say submit a Pokemon. And then when we start fetching a new Pokemon, then we can say set status pending. And so then we can have this represent if the status is pending, then we want to return a ... to indicate to the user that we're pending. When we have a successful request, then we can say set status to resolved. And if we're resolved, then we want to return the Pokemon data. So if the status is resolved, then we'll return the Pokemon data in a pre-tag here. And then if there's an error, we'll say set status rejected. And down here, we'll say status is rejected. Then we'll render, oh no. And so now our render method is very predictable, and we always know when our component is going to render what. So now if I try to type in mu again, we're going to see submit a Pokemon first, then we'll see ... while it's pending, and then we'll see oh no when it's been rejected. And so we'll fix our typo right here. We'll save that. And now we see submit a Pokemon because we're idle. We'll type in mu, hit submit, we get that ... and then we see mu's details. And if we try another Pokemon, then we'll see a ... and we'll see that Pokemon's details. So let's go ahead and review. We added some error handling by creating some error state management, and we added an error handler to our promise chain. So if we get some error data, then we're going to set that error data so that we can render something useful to the user, indicating that there's been a problem. And then to avoid some state bugs, we added a status state so that we could start out with idle, and then when we start fetching the Pokemon, we can set it to pending. And then when we get the Pokemon, we can set it to resolved, or if there's a failure in getting the Pokemon, then we set it to rejected. And that helps us to avoid bugs. So here I can fill out a Pokemon name like Pikachu, and I submit and I get some Pikachu data. But if I make a typo here, then I'm not going to get anything back, and it might be useful for me to get an understanding of what's going on behind the scenes in the state of the components that I'm rendering to this page so that I can debug the problems that are happening in my components. And so what I'm going to do is I'm going to Google React Dev Tools, and that'll come up with the Chrome Web Store for React Dev Tools. There's also React Dev Tools supported for other browsers, but I'm using Chrome, so I'm going to add this to Chrome. Click on Add Extension. And then React Developer Tools has been added to Chrome, so I can use that by clicking on that icon. And when I come back to my app, I'll go ahead and refresh here, and we'll see that Chrome extension icon for React Dev Tools has turned red, and that's indicating to us that React is on this page and we're using the development build of React. When we use the production build of React, then this will look a little differently, and we can see that by going to twitter.com, because Twitter is built using React. And so here, this page is using the production build of React. If we close this and now I open up my DevTools, I can go inspect here, or I can go here to more tools and developer tools. That'll open up the developer tools here. And if I click here and look at components, then this is going to show me the components that are driving this page. So I can see that we have an app component and we have a Pokemon info component. And under the app component, I can see all of the hooks that are being used for this app component to work. We have some state here that is an empty string. And as I type in here and click submit, now we see that that state is what I typed. We can even change that value here. We can click undo if we want to undo that change, or we can hit enter to commit that value. And now that value has been committed, and you will see that we get null is printed because there is no Pokemon by the name of value. But if we change this to Mew and hit enter, then we're going to retrieve Mew's information. And then on the Pokemon info side, we can see the Pokemon name is coming in via props. And we can actually change this prop to Mew2, change that prop there. And then we can also see the hooks that are being used by the Pokemon info component. We have state is resolved. We also have some more state for the Pokemon information itself, and some more state, and this is for our error state. And we can see this hook also has an effect. And there are a lot of options that we have here, so we can click on this, and that will show me the source code for this particular component. If we go back to our components here and click on this button, then that will log this component's information to the console, and we can click that to expand it. We'll see the props, the hooks, and the root DOM node that's being rendered by this component. And we'll come back here again. And if you want to, you can actually drag this over, since we're going to be using this a lot. So I'm going to move that over there. We also have this button to inspect the matching DOM element. That'll take us straight to our Elements tab here with that element highlighted. And then this is for suspense. So if you're using any React suspense components, you can test those out here by suspending the selected component. We also have some options here for the theme and the way that this is displayed. And then we also have some view options for our components tab, where we can filter out different types of components or even filter them out by their name. So if we wanted to get rid of that app, then we could type that in. And now our app is no longer being shown. But I do want to show that, so I'll remove that. And now our app is being shown. And then we also have a profiler tab that will help us debug performance issues in our app. And so we can enable record while each component is rendering, and we can also hide commits below a certain threshold. So if a commit is really fast, maybe it only takes 5 milliseconds to update the DOM, then we can enable that. And now I can go to my profiler. I'll drag that over here as well. So we can hit this button to start profiling where we are, or we can hit this button to reload and start profiling when the page loads. So we'll click on that, and then we can click stop, and we'll see that there's no data matching the current filter criteria. So let's go ahead and we'll uncheck this button. And now we can see that there was a commit, and it just happened really fast. And that commit was for the initial render of our components. So we have our app and our Pokemon info, and it says that this was rendered because it's the first time that it was rendered. And now let's go ahead and do another recording. We'll say Mew, we'll submit that, and then hit stop. And we'll see a couple of commits here. For this one, it re-rendered because hooks changed and props changed. For this one, it re-rendered because hooks changed. And on this commit, it re-rendered because hooks changed again. So the data came back from the Pokemon request. And then this re-rendered because we updated our state. So the React DevTools gives us this components and this profiler tab in our developer tools to give us a lot of insight into what our components are doing while we're developing them. And then we also have this indicator up here to tell us when we're using the development build of React versus the production build, so we can make sure that our production application uses the production build. One last pro tip I want to show you is if you open up the console while you have the components tab open, and you can do that by hitting the escape key, then we have our console here. You can type $R, and that will give you the hooks, the props, and the type for the component that you have currently selected. So we can click on the app, we can do $R again, and now we'll see the hooks, the props, and the type for that component that we have selected. This is actually very similar to the Elements tab where you can do $0, and that will give you the DOM node that you have currently selected in the Elements tab. So in the Components tab, you have a $R, and that will give you information on the component that you have currently selected. So I strongly advise that you install the React DevTools and play around with them so you become familiar with their capabilities and make you more productive developing React applications. Once you've figured out how React works locally in an index.html, you probably want to build an actual application, and the best next place to start is by going to codesandbox.io. CodeSandbox is amazing. It's an entire IDE and prototyping tool for rapid web development built right into the browser. It's just like a typical development environment that you would expect from a local development. So let's go ahead and create a sandbox. I'm going to create a React sandbox here from the React template. And here on the right, we have our browser. On the left, we have our sandbox. And I can say, hello, you, ! And it just gets updated automatically as we go. There are a ton of things that you can do in CodeSandbox. You can add dependencies from NPM. You can add external resources. You can even change your typeface. And if we hit Command and a comma, you can open up your settings here and change the settings just like you would if you were using VS Code locally. It's really amazing. So you can build your whole app out here. You can have multiple files and use import statements and modules. You can even write tests in here. So we could create a new directory called tests. And then in that directory, you can have a test.js file. And then we click on the test tab here and we get to run all of the tests that we have in here. So we can say test, this works. And then our test will be run. Another thing you can do with this is you can connect this with GitHub. So I'm going to go ahead and sign in with GitHub right here. And I'll authorize CodeSandbox. And then we'll sign in right here to authorize CodeSandbox to create repos. And then I can create a new repository. Example CodeSandbox. We'll click Create Repository, and CodeSandbox will create a repository on GitHub based on what I have right here. And with that now, I can go to the information here and I see that there's a link. I can click on that, and that opens up in this new GitHub repo that has all of the code that I had for that CodeSandbox. To take it a step even further, I can go to this deployment option and I can deploy this with Now or Netlify. So let's go ahead and try deploying this with Netlify. We'll click Deploy. And then I get a sandbox site. And now Netlify is building my CodeSandbox. I can look at the logs here, and it's going to take a minute or two to complete. So I'll speed that up for you so you don't have to wait. And now it looks like it's been deployed. So I can scroll through all these logs and take a look at what it's done here. And then I can click Visit. That will pop open the site in another tab. And this is available on the World Wide Web, so you can send this URL to anyone and they can see the amazing work that you created within CodeSandbox. You can also claim this site so you can make it associated to your Netlify account and even have it wired up to the GitHub repo that you have. So anytime you push changes to this GitHub repo, you can get your site redeployed. Within Netlify, you can even make a custom domain. And so you could create an entire application using just CodeSandbox, Netlify, and GitHub. Oh, and as you make changes, for example, if we say hello there, then CodeSandbox will automatically fork your sandbox and you can commit changes to the GitHub repo that this CodeSandbox is attached to. So we could say change title. We could commit it directly or even open a PR. So let's go ahead and commit. It'll create the commit and put it in our repo here. And now we see change title was the latest commit. And if we wire up Netlify to our GitHub repo, then Netlify will automatically deploy that change as well. So you can work entirely in CodeSandbox, or if you'd rather work locally, then you can also export this to a zip, unzip that and work through it locally, or you can clone this repository and work through it locally as well. There's an entire world of things that you can do with React once you have these tools at your fingertips, and I look forward to seeing the cool things that you build to make the world a better place with your newfound knowledge of React. Did you have a good time? I had a good time. I hope this gave you the foundation that you need if you're just getting started with React so that you can build upon this and make amazing experiences with React. If you've been using React for a while and you just came here to solidify your understanding of the fundamentals, I hope this did that for you too. I'm excited about React because I think that it can make the world a better place by making us more productive in building the applications that we're building for our users. And I hope that you take the opportunity to build some amazing experiences with this amazing library that we have, that we love, that we call React.